Okay, so welcome to my class. Our topic for this session is all about the introduction to differential equation. So by the way, I'm Engineer Anthony T. Reyes, a faculty of Bulacan State University under the College of Engineering, specifically from Electrical Engineering Department. So welcome and let's start. This session covers the topics about an overview of differential equations, the classification of differential equations, the order and degree of differential equations, and lastly, we have the linearity of the differential equation. So let's start with the overview to differential equation. First is differential equation is defined as an equation containing derivatives or differentials of one or more variables. So for example, you will have dy over dx equals e raised to x plus sine of x. This is an example of differential equation because of the dy over the dx. Another example is y double prime minus 2y prime plus y equals the cosine x. This is also considered as differential equation because of the y double prime, which means the second derivative, and also the y prime stands for the first derivative. Next example is the quantity of x squared plus y squared multiplied to dx minus 2xy dy equals 0. Also considered as a differential equation because of the dx and the dy. Next example is L multiplied to the second derivative of I with respect to t plus r multiplied to the first derivative of I with respect to t plus I over c equals e multiplied to the omega multiplied to the cosine of the omega t. This is also considered as differential equation because of the second derivative of I with respect to t and also the first derivative of I with respect to t. And lastly, you will have the x multiplied to the partial derivative of f with respect to x plus y multiplied to the partial derivative of f with respect to y equals to n multiplied to f, also considered as differential equation because of the partial differentiation. Then next is the classification of differential equation. Now you have to classify every differential equation in every given equation. First is we have the ordinary differential equations or the ODE defined as the equations which all derivatives are ordinary derivatives of one or more dependent variables with respect to a single independent variable. Now, for example, you have the dy over dx equals the cosine x. Then another example is the second derivative of a y with respect to x plus the first derivative of y with respect to x equal y. Then another example is the third derivative of x with respect to y plus x multiplied to the first derivative of x with respect to y minus 4xy equals 0. And last example is the second derivative of y minus 3 multiplied to first derivative of y minus y equals to 0. Then another classification is we have the partial differential equations or the PDE defines as the equations which containing at least one partial derivative of some dependent variables. Examples are the partial derivative of u with respect to x minus the partial derivative of u with respect to y equals x minus 2y. Another example is the second partial derivative of v with respect to x plus the second partial of v with respect to y equals 0. Another example is the partial of u with respect to x plus u multiplied to the partial of v with respect to y equals v multiplied to the second partial of v all over with respect to x and y. Last example is x multiplied to the partial of f with respect to x plus y multiplied to the partial of x with respect to y equals n multiplied to f. Now, for you to be able to identify the equation, whether it's ODE or PDE, by simply looking at the equation, we have the simple comparison between the ODE and the PDE. The ODE uses a small letter d in the equation, while the PDE uses this kind of symbol. So, if you will see the equation, you will notice ODE with a small d in the equation. Then the PDE, you will see this kind of symbol. Now next is the order and the degree of the differential equation. Now for you to be able to identify the order of the differential equation, the definition of this is the order of the differential equation is the exponent of the highest order derivative appearing in the equation. So simply by identifying the highest derivative in the equation, that would be the order of what we call the differential equation. So for example, you have an equation of the second derivative of x with respect to t plus a multiplied to the first derivative of x with respect to t plus kx equals 0. This equation has a second derivative for the highest derivative in the equation. So therefore, your order is second order. So you will notice that this is second order by the second derivative of x with respect to t. Now another example is dy over dx minus cosine of x plus y equals 0. This equation has first order by this equation, the dy over the dx, or the first derivative in the equation. Next is the d squared y over the dx squared plus the quantity of dy over dx raised to 3 plus y equals a. This is second order by simply d squared y over dx squared, or what we call the second derivative, y. 3 is higher than 2. Kaya lang po, this means second derivative. And this equation means first derivative. The higher between the two is the second derivative. So you will consider this d squared y over dx, and that is second order. Next example, you have the second partial derivative of v with respect to x plus the second partial of v with respect to y equals 0. So if you will notice, this is partial differential equation because it uses this kind of symbol. But your target is to identify the order of this equation. So to identify the order of this equation, this is considered as second order. Kasi pag tinignan nyo po yung equation, this one, and also this one, this is both second derivative, or what we call the second partial derivative. So kahit alin po yung tignan nyo dyan, they are both second derivatives. So the order of this equation is second order. Now next is the degree of the differential equation. This is defined as the degree of the differential equation, which can be written as a polynomial in the unknown function and its derivatives is the power to which the highest derivative is raised. Or simply saying, identify nyo po kung alin yung highest derivative, then kung ano yung exponent or kung saan siya naka-raise, yun yung degree nung differential equation. O para mas madali, let's go to the examples. So first example is yung kanina. You have the second derivative of x with respect to t plus a multiplied to first derivative of x with respect to t plus kx equals to 0. So kanina, this is second order because of the second derivative. So identified na natin that this is your order. So dapat sa kanya manggagaling yung degree. So you have the second order, tapos kung saan siya naka-raise, since wala siyang raise dito, that's automatically raised to 1. So 1 stands for the first degree. So another example is the quantity of the y double prime squared minus 3y prime minus y equals 0. So identify first kung saan manggagaling yung order. So identify nyo muna kung ano yung highest derivative. You have the second derivative and the first derivative. So automatically, you will be having your second derivative. So this term, dito manggagaling yung order ng equation. So dapat dito manggagaling yung degree ng equation. So identified natin that you will have y double prime. Then the exponent of the y double prime is 2, which stands for the second degree. Next example is the quantity of the second derivative of w with respect to x raised to 3 minus xy multiplied to dw over dx plus w equals 0. So identified first kung saan manggagaling yung order. So you have the second derivative and the first derivative. So automatically you will be having this term. So dito po, you have the second order, but our target is the degree. So you have this term. Ang exponent ng term na to is 3, which means you will be having third degree. Then another example is d squared y over dx squared plus the quantity of dy over dx raised to 3 plus y equals to 0. So manggagaling yung order natin sa highest derivative. You have the second derivative and you do also have the first derivative. So we have the highest, which is the second derivative, which is the d squared y over dx squared. So ang exponent niya ay 1 stands for the first degree. Hindi po pwedeng kunin si dy over dx raised to 3 kahit na mas mataas yung exponent niya comparing to the second derivative kasi nga the degree is defined as the exponent of the highest derivative. Since ang highest derivative natin is second derivative, so you will be getting the exponent of the second derivative, which is 1. So this equation has first degree. Next topic is the linearity of the differential equation. Okay, you have to identify if the equation is linear or nonlinear. How? A differential equation is linear in a set of one or more of its dependent variables if and only if each term of the equation which contains a variable of the set or any of their derivatives is of the first degree in those variables and their derivatives. Then considered as nonlinear if a differential equation in some dependent variable is said to be nonlinear in that variable. A differential equation which is not linear in the set of all the dependent variables is simply said to be a nonlinear differential equation. So how to identify it? First, let's say we have the example of y double prime minus y prime plus y equals 0. So you will be having the dependent variable of y. Then this equation is considered to be linear differential equation. Next example, you have the y double prime plus 5y multiplied to y prime plus y equals to cosine x. The dependent variable here is y. then this is considered as nonlinear differential equation because of the term 5y multiplied to y prime. Another example is y double prime plus 4xy prime plus 2y equals 0. Then the dependent variable here is y. Then this is considered to be linear. Then number 4, you have the partial or the second partial of u with respect to x plus the partial of v with respect to t plus u plus v equals 0. This is dependent, you have the dependent variable of u and v. Then this is considered to be linear differential equation. Next example is the second partial of u with respect to x plus partial of v with respect to t plus u plus v equals the sign u. Then you have the dependent variable of u and v. Si u nakadepende kay x, tapos si v nakadepende kay t. Then, this is considered to be nonlinear because of the term sine of u. Then last example is the first derivative raised to 2 plus y equals k. The dependent variable in this equation is y. Then this is considered to be nonlinear because of the term of first derivative raised to 2. And that's all for the topic. Now let's do some sample problems. In our sample problems, for each of the following equation, you have to classify the equation as ODE or PDE. Next is to identify the order. Next, again, is to identify the degree. Another one is to identify the dependent and independent variable or variables in the equation. Then lastly, you have to indicate if the equation is linear or nonlinear. So example number 1, you have the d squared x over dt squared plus k squared x equals 0. So if you will look at the equation, it uses d. So automatically, the classification of this equation is ODE. Then for the order of this equation, you have the second derivative as the highest derivative in the equation. So the order is second order. Then identify mo kung ano yung exponent ni second derivative. The exponent of the second derivative is 1, stands for the first degree. Then identifying your dependent and independent variable, this equation has dependent variable of x, then independent variable of t. Meaning to say, si x nakadepende po sa magiging value ni t. Then this equation is considered to be linear. Another example is you have the partial or the second partial of w with respect to t equals a squared multiplied to the second partial of w with respect to x. Since it uses another or other symbol instead of d, so it will be considered as PDE. Next is the highest derivative in this equation is second derivative. So you will be having second order. Tapos, kahit alin sa highest derivative niya, which is the second, the exponent there is 1 and the exponent here is also 1. So ang degree natin is first degree. Then we do have the dependent variable of w and the independent variable which is t and x. Meaning to say, si w po nakadepende kay t and x. Then this will be considered as linear in terms of x and t. Next example is the quantity of x squared plus y squared multiplied to dx plus 2xy multiplied to dy equals to 0. So first, we have to simplify the equation in terms of dy over dx, or it can be dx over dy. So let's check. In terms of dy over dx, the equation will be the quantity of x squared plus y squared plus 2xy multiplied to dy over dx equals 0. But in terms of dx over dy, you will be having the quantity of x squared plus y squared multiplied to dx over dy plus 2xy equals to 0. So, parehas naman sa equation, it uses d in the equation. So, the classification of this is ODE. Now, let's identify the order of this equation. The highest derivative in this equation is the first derivative in both conditions. So you will be having first order either in dx over dy or dy over dx. Then to identify the degree, identify the exponent of the first derivative. So you will be having first degree since ang exponent ni dx over dy is 1 and the exponent of dy over dx is also 1. Then identifying the dependent and independent variable. In this equation, if you will be having dy over dx, kasi pwede siyang in this form at pwede rin siyang in this form. So either variable x or y can be dependent or independent. In this equation, the independent variable is x and then the dependent variable is y. But in this equation, the independent variable is y and the dependent variable is x. Then lastly, this is nonlinear in x and y. Why? If you will notice in this equation, you will be having 2xy dy over dx. Then, dito naman sa kabila, you will be having x squared multiplied to dx over dy. Then number 4, you have y prime plus the p of x multiplied to y equals the q of x. So, dapat naka dy over dx or naka dx over dy. Then, let's check. If you will be having the term of dy over dx, the equation will be dy over dx plus the p of x multiplied to y equals q of x as is. The same, just change y prime into dy over dx. But in terms of dx over dy, the equation will be 1 plus p of x multiplied to y multiplied to dx over dy equals the q of x multiplied to dx over dy. So in the equation, it uses d. So this is ODE. Then identify first the highest derivative. So we will be having first order in terms of dy over dx or dx over dy. Then next is first degree since the exponent of both sides is also is 1. So any equation, it will be having first degree. Then again, it can be either variable of x or y, dependent or independent. Then lastly, this can be linear in y, but nonlinear in x because of the term p of x, y, dx over dy, and also q of x multiplied to dx over dy. Then we have y triple prime minus 3y prime plus 2y equals 0, wherein y triple prime stands for third derivative, then y prime stands for first derivative. So, this can be considered as ODE kasi si y prime is dy over dx tapos si y triple prime is d cube y over dx cube. So it uses d. So this is ODE. Then for letter B, this is third order because the highest derivative in this equation is third derivative because of the y triple prime. Then you will be having first degree kasi the exponent of your third derivative is simply 1. So 1 stands for first degree. Then the dependent is y. Then the independent is x because of the y prime or the y triple prime. You will be having dy over dx. Then this equation is considered to be linear. So that's all for this session. I hope you learned something new in our session. So thank you and God bless.